Next category is the semi-solid lubricants or the greases. The greases are semi-solid lubricants consisting of soap dispersed in a petroleum oil or synthetic oil. Means we can use an oil as a base and mix soap in it. So, we have calcium based greases, soda based greases, lithium based greases and axle based greases. 4 types of greases are there: calcium based, soda based, lithium based and axle based. Calcium based greases, these are emulsions of petroleum oil and water containing calcium oleate, and these are insoluble in water. Means we can use these greases where lots of water is used. Then lithium based greases, these greases are petroleum oils gelled with lithium soaps. These are water resistant and suitable for use at low temperature. So, when petroleum oils are mixed with lithium soaps, these become lithium based greases and these can be used at low temperatures and where lots of water is used. Then we have soda based greases. These greases are prepared by mixing sodium soaps with the petroleum oils. Now, these are water resistant because unlike calcium soaps, sodium soaps are soluble in water. Then we have axle greases. These are prepared by adding lime or any metal hydroxide and resin to fatty acids. Yani we add lime, calcium hydroxide or any other metal hydroxide like magnesium hydroxide or aluminum hydroxide and a resin to the carboxylic acids, and these are water resistant. Now, are the applications of the greases. Where can we use greases as a lubricant? Machinery that runs intermittently or is stored or is idle for prolonged periods. That is, the machinery which we run for a few days and then keep it for a long time and stored for a long time, and it is lying idle. There the greases are used because greases remain in place and a lubricating film is instantly formed. Okay, greases are there, they will not take off the machine part. Second is machinery that is not easily for frequent lubrication, means the machinery where frequent lubrication cannot be done. We cannot apply oil again and again. Now, these greases are also used in sealed for life applications such as some electrical motors and light applications such as electrical motors and gearboxes. Then we have machinery operating under extreme conditions such as high temperature and pressures, because at these temperatures and pressures the lubricating oil will either evaporate or decompose. Shock loads or slow speed under heavy load, because shock loads and slow speed will take off the lubricating oil from the machine. Then grease also maintains thicker films in clearances enlarged by wear, and it can extend life of worn parts that were previously oil lubricated. Means sometimes what happens is ki we are using the lubricating oils, but even with the passage of the time the machine wears off and large spaces are created. So, we can seal those places with the use of a grease. Thick thicker grease films also provide the noise insulation, means they also stop the noise in the machine. Third category is the solid lubricants. Solid lubricants are used where operating conditions are such that a lubricating film cannot be secured by the use of lubricating oil or greases. That is, the lubricating film of oil or grease cannot maintain itself on the machine part. Second is contamination by the entry of dust or dirt particles of lubricating oils or grease is unacceptable. That is, what happens is कि lubricating oil and grease, these are going to invite the dust or dirt particles to settle on the machine, and we cannot afford that contamination, and those are electric generators and motors. That is, the machines where electricity is generated, we cannot afford to have dirt or dust particles. There we are going to use solid lubricants. Third is the operating temperature is too high even for a semi-solid lubricant to remain in position. Now, at high temperatures sometimes we use semi-solid lubricant, but that lubricant cannot remain in position because of the higher temperatures. Therefore, we use the solid lubricants there. Now, the inorganic solids which are used as solid lubricants are graphite, hexagonal boron nitride, molybdenum disulfide and tungsten disulfide. Once again, the inorganic solids which we use are graphite, hexagonal boron nitride, molybdenum disulfide and tungsten disulfide. Now, the use of some such materials is sometimes restricted by their poor resistance to oxidation, that is, they react with oxygen. For example, molybdenum disulfide can be used only up to 350 degree centigrades, but where the reducing environments are present, that is, carbon is present, hydrogen is present, there its working temperature increases to 1100 degree centigrades. Now, the important solid lubricants are, first is graphite. It is most widely used of all solid lubricants, means graphite is most commonly used solid lubricant. It is soapy to touch, non-inflammable, means does not catch fire easily, and is not oxidized in air below 385 degree centigrades. It means the oxidation of graphite does not take place less than 385 degree centigrades. It is used up to very high temperatures. Now, where graphite is dispersed in oil, then it is called oil dag, and when it is dispersed in water, it is called aqua dag. So, that is, graphite can be used in two ways, by mixing it with oil or by mixing it with water. If it is mixed with oil, then it is called oil dag, and if it is mixed with water, then it is called aqua dag. On the other hand, the aqua dag is useful where a lubricant free from oil is needed. For example, food stuff industry. That means, in food industry we can use graphite as a lubricant. Now, this is the structure of the graphite. So, we can see that these circles, these black circles are actually the carbon particles, and these are placed hexagonally. 1, 2, 3, 4, 5 and 6 sides are there. This is one layer, this is second layer and this is third layer. So, all these layers, these actually slide over each other when we apply them. That is why graphite can act as a lubricant. In the same way, boron nitride also has hexagonal structure. The black circles are the boron particles and the blue circles are the nitrogen particles. Just like graphite, boron nitride also has different layers which can slide over each other. That is why boron nitride can also be used as a lubricant. Next solid lubricant which is commonly used is molybdenum disulfide, MOS2. Molybdenum disulfide possesses very low coefficient of friction and is stable in air up to 430 degree centigrades. Now, its fine powder may be sprinkled on surfaces sliding at high velocities when it fills low spots in the metal surfaces, forming its film. It means that the metal surfaces, if they have some cracks in them, then we can sprinkle molybdenum disulfide. It will fill those cracks and make the machine parts move easily, and its working temperature is 430 degrees centigrades in air. After that, it oxidizes. Then it is also used along with a solvent and in greases, means we can use molybdenum disulfide as a powder or in a solvent or in the greases. Next lubricant is polytetrafluoroethylene, which we commonly remember as Teflon. So, polytetrafluoroethylene PTFE is typically used as a coating layer on cooking utensils to provide a non-stick surface. Now, it can be used up to 350 degree centigrades and it is chemically inert. Therefore, it can be used in the foodstuff industry for making utensils and in greases. Under extreme pressures, PTFE powder or solids cannot be used because then it becomes soft and flows away from the area of contact. Means we cannot use polytetrafluoroethylene at very high temperatures. Now, Teflon, which we know is the brand of PTFE owned by DuPont Corporations. Now, this is the structure of PTFE. This is tetrafluoroethylene, which is a monomer, where green circles are the carbon atoms and the blue circles are the fluorine atoms. So, it joins in this way. These are the two carbons of one, here we see one carbon, second carbon, and these are the two fluorines. Then next monomer tetrafluoroethylene combines with it and we get a polymer. Now, metal alloys or composites and pure metals can be used as grease additives or the sole constituents of the sliding surfaces and the bearings. Cadmium and gold are also used for plating surfaces, which gives them good corrosion resistance and sliding properties. Thank you.